This river of fire is not lava. It is the beginning of modern civilization. Inside this furnace, solid rock is transformed into liquid metal.
Temperatures here exceed those found in volcanic eruptions.
Every second, tons of material are chemically rewritten. At the heart of every steel plant stands the blast furnace. Human survival here depends on precision, not proximity. But this journey begins with nothing more than rock. And fuel engineered to burn hotter than coal ever could. Once ignited, a blast furnace never truly sleeps. Shutting it down could destroy it forever.
Iron ore is extracted from massive open-pit mines across the world.
These pellets contain iron oxides locked tightly inside stone. Coke is produced by heating coal in oxygen-free ovens.
The result is nearly pure carbon, engineered for extreme heat.
Limestone is mined to remove impurities during iron making.
Each raw material plays a precise chemical role inside the furnace. Incorrect proportions can destabilize the entire process. Every batch is measured with extreme precision. Materials are lifted hundreds of feet to the furnace top. At the top, the furnace accepts its raw ingredients.
Iron ore, coke, and limestone begin a long descent.
Inside, temperature and chemistry change dramatically by the meter. This structure contains multiple processes layered vertically.
The internal temperature on Forge 2 is spiking faster than projected.
Cross-reference that with the oxygen input levels. Let's stabilize the flow.
Now, the most extreme transformation begins.
Superheated air is blasted into the furnace base at immense pressure.
Coke ignites immediately, generating the heat that drives the entire process. Carbon reacts with oxygen, forming carbon monoxide gas. This gas moves upward, carrying energy through the furnace. Carbon monoxide removes oxygen from iron ore in a reduction reaction. Pure iron begins to emerge from solid rock.
As temperatures rise, iron melts and flows downward.
Limestone breaks down, preparing to remove unwanted impurities. These impurities combine to form a separate molten layer called slag.
Molten iron settles beneath slag due to its greater density.
The furnace structure constantly expands under extreme temperatures.
Cooling systems prevent the furnace from destroying itself. Molten iron accumulates like a lake at the furnace base.
When ready, operators drill open the tap hole. Liquid iron escapes under immense pressure and heat. Refractory channels guide metal safely away from the furnace. Slag is removed separately, floating above the iron. Even waste products are carefully managed and reused.
This cycle continues around the clock, every day.
Human expertise remains critical at every stage. Thousands of sensors continuously track internal conditions. Pressure control prevents catastrophic failure. Errors here can escalate in seconds.
The molten product is now known as hot metal.
It must remain molten as it travels to steelmaking. Special insulation prevents critical heat loss. Samples are taken immediately to verify composition. Carbon content determines how the iron will be used. Even small variations matter at industrial scale. The furnace never pauses its operation. Some blast furnaces operate continuously for decades. Internal linings slowly erode under constant attack.
Maintenance requires precise planning and rare shutdowns.
Cooling the furnace improperly can destroy it entirely.
This is industrial chemistry at its most extreme.
Blast furnaces rely on reduction chemistry, not melting alone.
Gas movement determines how efficiently iron ore is reduced. Carefully controlled heat gradients regulate reaction speed. Refractory linings must survive years of constant thermal assault.
Structural forces push materials close to their physical limits.
Operator experience is as important as automation.
Warning systems respond instantly to unstable conditions. Redundant cooling systems protect the furnace from failure.
Digital systems now oversee thousands of variables simultaneously. But human judgment remains the final safeguard. New furnace designs aim to eliminate carbon emissions entirely. Hydrogen could replace coke as the primary reducing agent. Existing furnaces are becoming cleaner through carbon capture.
Artificial intelligence now improves efficiency minute by minute.
Even century-old technology continues to evolve. The future of steel is being forged right now. From solid rock to flowing metal, the transformation is complete. Every steel mill, bridge, and machine begins with this process. Blast furnaces quietly support the structure of modern life. This is how iron is born.